Okay, so I've been spending the first half of lecture talking primarily about the first set of communication networks in your body, the nervous system. And now I'm going to actually diverge a little bit and talk about a second communication network in your body, and that is the endocrine system. And if I were to compare these two systems to one another, the nervous system is really like it is the Autobahn of information. It is transmitted very quickly, it's super fast rates. But the endocrine system, what it does as a second communication network in the body is it allows the body to continue receiving signals for a little while. And so it's a very slow network by comparison. So within the nervous system communicates information both electrically and in the form of neurotransmitters. But in the endocrine system, in the system of glands located throughout the body, it actually uses a different chemical, hormones, that it sends its messages by being released into the bloodstream. So all of these glands, the reason why they're considered an endocrine gland or an endogenous, an internal organ that communicates information throughout the body, is because these different glands emit different hormones, different signals into the bloodstream, and these hormones, they go to our various muscles and tissues and sometimes even other glands. Now, the thing about hormones themselves is as far as their function, is they regulate a lot of physical processes, again, a lot of them involuntary, throughout the body. So, for example, metabolism, digestion, actually absorbing nutrients from the food that we eat. Hormones play a significant role in that. For example, insulin. They also play a role in our actual physical growth, in the digestion process, in sexual development, and also the sexual response cycle, I might add. And for women, it plays a very important role. There's a very complicated hormonal process that occurs that governs the menstrual cycle, and with that there's very complicated process of hormonal exchange that governs pregnancy to be even able to physically carry a child to full term. The other thing that hormones do is they actually are very heavily involved in our emotional experiences as well. And so earlier I was talking about the sympathetic nervous system, and that its primary function is the fight or flight response, to arouse us and alert us and, to startle us, so to speak, so we respond to some kind of threat in our environment. But anybody who has actually been startled notices that while the process can, happen very, very quickly, sometimes it takes a good 15 to 20 minutes to calm down after being startled, after we realize there is no real danger or threat in the environment. It takes a long time for these responses to kind of go away and for us to calm down, and that's because hormones, they stay in the bloodstream a lot longer than neurotransmitters stay out in their synaptic gap affecting other neurons. With hormones, it takes at least 20 minutes for them to be cycled out of the bloodstream, so to speak, so long as they're no longer being sent. So that's one reason why after particularly frightening experiences, it can take a little while to calm back down. So the first endocrine gland we're going to talk about is the pineal gland. What it does is the hormone it manufactures is melatonin and not melanin, which is skin pigment, just in case anybody ever gets confused between those two words. But what the hormone melatonin does is it governs the sleep-wake cycle, and we're going to talk about this much more in depth when we get into the consciousness chapter. But when there is an excessive amount of melatonin being released into the bloodstream, it makes the person incredibly sleepy, and so usually at night is when humans have the greatest concentration of melatonin in their bloodstream. Of course, this can get thrown off by a number of different environmental factors, such as sleeping with the lights on, getting irregular sleep, etc., and we'll go into that when we get into the consciousness chapter. Another endocrine gland, which is actually also a brain structure, and that's kind of rare because not often are endocrine glands also brain structures. This is the only one. But the hypothalamus is actually the link between the two communication networks of your body, your nervous system and your endocrine system, because it produces both neurotransmitters, which is the language of the nervous system, and hormones, the language of the endocrine system. So because that it produces both types of chemicals, it can regulate this, it can regulate the activity of the endocrine system along with activity in the nervous system. So, and we're actually going to talk about the hypothalamus again later on when we actually talk about brain structures, but just remember that it is the link between the nervous system and the endocrine system. The pituitary gland as an endocrine gland is actually, it's got a very interesting story. It is known as the master gland because the hormones that it produces actually regulate the production of all the other hormones by all the other endocrine glands in the entire endocrine system. No endocrine gland can release its hormones without being told by the pituitary gland first. So it is kind of known, it's the boss, so to speak. But it actually manufactures its own special type of hormone which no other endocrine gland really manufactures, and that is growth hormones, pituitary growth hormones. And so when people experience a deficiency in growth hormone, especially early on in life during childhood, this can seriously stunt physical growth. And actually one of the types of dwarfism is known as pituitary dwarfism because it is the result of a deficiency in growth hormone during the growing phase, during childhood. And a lot of times this can actually be corrected. If this is identified early on enough for a child, they can begin a treatment for growth hormones and catch up to relatively normal average height by the time they're in adolescence, which is the time usually when most people experience their last major growth spurt. The thyroid gland is an endocrine gland that is responsible for controlling metabolism. That is its primary function, and it does so by releasing a couple different of hormones, but one of which is very important, thyroxine. Now, thyroxine is a hormone that when it is released in our bodies, and when there is a lot of it, we start to burn off energy. The foods we eat, we break them down a lot faster. We use the calorie content a lot more quickly. So basically, we can burn energy. But if we have too little thyroxine, the metabolic process of our body starts to slow down. We start to gain weight and become sluggish and very tired and fatigued. And this is actually a problem. People who have thyroid glandular disorders often report, and that could be one of two varieties. Either their thyroid gland is producing too much of this hormone and they have a lot of difficulty gaining weight because they can eat and eat and eat, but their body just burns off that energy very, very quickly. Or they could have the opposite problem in which their thyroid gland does not produce nearly enough, and so even though they've been dieting and they've been exercising and trying to lose weight, they're struggling just to make it through their day-to-day activities. Next set of gland in the endocrine system, very important, we'll talk about these again throughout the semester, are the adrenal glands. Okay, now there's actually two layers of the adrenal glands. You don't need to remember what the difference is, but the adrenal cortex is the outer layer of your adrenal glands, and you guys, as you notice, there are two of them, and the adrenal medulla is actually the inner portion of the adrenal glands. Now, these are important because when that sympathetic nervous system is aroused, remember the fight or flight response, it actually signals the pituitary gland, which then turns around and signals the adrenal glands to start releasing epinephrine, which is very, very similar to norepinephrine, that neurotransmitter that we just talked about. And so it actually acts as both hormone, as a hormone and a neurotransmitter, depending on where in the body it gets released. But what that does is it gets released into the bloodstream, and so when that fight or flight response is activated and you notice that it takes a little while for you to calm down afterwards, that's because your adrenal glands have released epinephrine in your bloodstream, which gets sent to your muscles and your lungs and your heart, which prepares them to expend a lot of activity. It's a very excitatory hormone and neurotransmitter. The pancreas is an endocrine gland that is very important in regulating your blood sugar and insulin levels, so it also plays a very important role in, our state of physical energy, which can certainly, if we have low energy, can certainly have an effect on our cognitive and emotional experiences. But it does so by producing insulin. That is its hormone. And what insulin as a hormone does is it helps signal the body to absorb glucose, very simple sugars, from the bloodstream, because glucose is one of the main molecules that all cells in the body use to function and continuing to communicate, for example, for neurons to be able to produce their neurotransmitters. Okay, it needs glucose. And so having insulin is what allows our body to use it as an energy source. And so it's also involved in our perception of hunger. Now, if anybody is familiar with diabetes and people with, depending on whatever type, type 1 or type 2 diabetes that they develop, have to usually take some type of insulin injection in order for them to actually use glucose as an energy source, because what happens in diabetes is the body doesn't produce enough insulin, and so what happens is glucose then starts to build up in the bloodstream. It cannot be absorbed or used as an energy source, and glucose is highly toxic to tissues and in the bloodstream, and a whole slew of various physical disorders and health crises can result from having too much glucose in the bloodstream. And so in order for them to eat most foods, people with diabetes have to usually take daily insulin injections, so that way they can control the symptoms of their disorder. The last set of endocrine glands that we are going to talk about are the system of glands that regulate both sexual development, behavior, and the reproductive process, and those are the gonads. So if anybody has ever heard the term or the phrase getting kicked in the nads, now you know where that comes from. But for men and women, this particular set of glands differs. In women, their gonads are known as ovaries. Okay, so you can see that here, and the ovaries are actually hanging off here to the side. Okay, this is the uterus, but these over here, these little white things, if you can see, are the ovaries. Okay, and the hormone they manufacture, actually several different hormones, but the group of estrogens, estrogen and progesterone. And in men, they have testes, these testicle sacs. Okay, hormone it manufactures is testosterone, and when these hormones are released in the body very, very early on, before we're even born, during the prenatal period, these hormones start getting released in the brain, depending on if women have an XX chromosome or if men have an XY chromosome. And so what happens is these hormones start to feminize. In the case of women, estrogen and progesterone released in the brain early on in our prenatal life starts to feminize the body and the appearance, and for men, testosterone masculinizes their appearance. But later on, as most women are probably aware of, these hormones are very intimately involved in the menstrual cycle, and either the amount of these hormones available in a woman's body dictates how her menstrual cycle occurs, when it occurs, and also are very important in pregnancy. Now, I do want to illustrate with testosterone that while yes, it is a male hormone, that it's not only released in men, it's actually also used in women. Okay, but the way it is used in women is that it is involved in the sexual drive. So testosterone, although it is a masculinizing hormone, it is actually used in the sexual response cycle of both men and women. And so, and just kind of as to give you an idea that these hormones, particularly estrogen and progesterone, I mean, men have these hormones as well, and women also have testosterone, but what really separates men and women hormonally is that women have considerably more estrogen and progesterone than men do, and vice versa for men.